Hi, hello everyone. Today we are going to see about controllability. So the system is said to be controllable if the during the interval 0 comma t the given system is x dot equal to a of t of x plus b of t into u. If every pair of vectors x naught x1 belongs to r power n, there is a control u belongs to lm square of 0 comma t such that x of t, and if x of 0, if we substitute controllable means it steers from the initial point to the final point. If x of 0 is x naught and x of t equal to x1, using the control when u is such that the corresponding solution of x dot equal to a of t of x plus b of t of u satisfies, and it steers from x naught to x1 during the interval 0 comma t is said to be controllable. So based on the theorem, the system x dot equal to a t of x plus b of t u is said to be controllable on 0 comma t if and only each vector x1 belongs to r power n, and there is a control u belongs to lm square of, this is the square integrable function which steers from 0 to x1 during the 0 comma t. So what we have to do means we have to assume the system is controllable, then we have to prove u steers from 0 to x1, and then we have to assume that u steers from 0 to x1, and then we have to prove the system is controllable. First, we assume the system is controllable uh, during the interval 0 comma t. Okay. Then from the definition there is a control. From the definition of control u of t, which steers from x naught to x1 for any pair of vectors x naught belongs x1 x2 belongs to r power n. From the definition of control itself, we know that it steers from x naught to x1. To prove that, but since 0 belongs to r power n, we may take 0 also belongs to the r power n matrix. So we take x initial point as 0. So x naught equal to 0. So u steers from, what we have to prove means u steers from x naught to x1. So we take x naught equal to 0, then it steers from 0 to x1 during the interval 0 comma t. So sufficiently what we have to prove means it exists x0 and x1. Okay, so u steers from x0 x1 belongs to r power n means we have to assume that x1 bar equal to x1 minus x of t comma 0 x0, that is also belongs to r power n. This is the constant matrix, and it is the constant linear combination of the x naught. So if u steers 0 to x1 bar during the interval 0 comma t means x of 0 equal to x naught, x of t will be x1 bar. So now the solution of 1 will be x of t comma 0 x naught plus 0 to t x of t comma s b of s u of s ds. So since x of 0 equal to 0 and x of t will be, x of 0 equal to 0 means x of t will be 0 to t x of t comma s b of s u of s ds. If we put x of capital T means we get 0 to t x of t comma t b of t u of t dt. Okay, then what we do means x of t can be written as x of t is nothing but x1 bar. So x1 bar can be written as x1 minus x of t comma 0 x naught equal to this term. So if we have to find we have to prove that x1 belongs to r power n. So we have to prove that x1 exists. So x1 equal to x of t comma 0 x naught plus integral 0 to t x of t comma 0 b of t u of t dt. So we take the system as controllable and we prove that x not x of 0 also equal to 0, that is 0, and x of t equal to x1 bar, which is x1. So we take the system as controllable and we prove that u steers from 0 to x1, and then what we do means we assume that u steers from 0 to x1 and we have to prove the system is controllable. So controllable means x of 0 equal to x naught, x of t equal to x1. So for the given solution of given solution x of t equal to x of t comma 0 x naught integral 0 to x of t comma s b of s u of s ds. So instead of t we have to put 0, x of 0, x of 0 comma 0 x naught plus integral 0 to 0. So 0 to 0 means it will be term goes out, and here 0 comma 0 means identity form, so identity into x naught, so it will be 1, so x of 0 equal to x naught, then we have to put t equal to t, which means x of t comma 0 x naught, and then 0 to t x of t comma t b of t u of t dt. So here is, it will be in the it will be in the form of x1, so instead of that we can put x1. So x of 0 equal to x1, x of t equal to x1. So the solution, x of 0 equal to x naught and x of t equal to x1, used years 0 to x naught to x1 during the interval 0 comma t. So the system is controllable during the interval 0 comma t. Hope you all understand, and thank you.